In this video, I will demonstrate performance of the chi-square test for goodness of fit. This is also known as the one-way chi-square or the simple chi-square. Now, this test is used when you want to examine outcomes that are categorical and see if the responses to this particular outcome or variable are significantly different. So, for example, if you have a questionnaire question in which you're asking people their preference on something or asking people to place themselves in a category such as gender or ethnicity or occupation or educational level, we can then use this to see if there are significant differences in the number of people that responded to each of the particular categories. So some of the assumptions we have when we do this particular test is that the samples are random. We assume that we have a random sample. We also assume that the observations are independent. In other words, each person or case can only be counted once or can only be placed in one of the categories. And again, we have to have a minimum of 2 categories, and we can have an almost unlimited number of possible categories, but each person can only be placed in or identify themselves with one category. So the logic of this test is basically going to compare the proportion of cases relative to an expected proportion of cases. So when we get the outcomes, the data returned from our questionnaire, or after we have people identifying each of their categories, in order to see if we have a difference in the responses, we have to have an idea of what the expected number of responses should be. So again, the outcome is going to be categorical. It has to be, someone has to fit into a finite number of possible categories. And so in order to test the null hypothesis that there is an equal proportion of responses across all the categories, we have to establish what the null hypothesis is. In other words, what's the expected frequency. So for example, if we had a question in which there were 4 possible categories and we had 40 subjects, the null hypothesis would be that there would be 10 people identified in each of the 4 categories. So there would be no difference among the proportion of observed frequencies compared to the expected frequencies. And so we can test that hypothesis, kind of an equal proportion hypothesis in which we expect the same number of people to be in each of the possible categories. Now we can also test the null hypothesis in which we might have kind of a criteria of what the proportions would be based upon previous research or based upon another population. So maybe, again, using my example of 4 possible categories, maybe in another population the proportion was different. It wasn't 10 in each category. Maybe it was 20 in one category, 5 in another, and so on. And so what we can do then is compare our current sample to this other population to see if our sample is different than the population based upon these expected frequencies. So in this example we have several variables. We're only going to test one variable, but we can test multiple variables simultaneously. And each of these variables represent different kind of categorical outcomes: marital status, whether or not you have children, your education level, source of stress, and whether or not you smoke. So these are all examples of situations in which we get a categorical outcome or categorical response. So the variable we're going to examine here is going to be smoking. So what we want to find out is whether the proportion of smokers in our sample is different compared to what we see in the literature from maybe a previous study. So in this case, we have our categorical outcome that has 2 or more categories, and people were only allowed to identify either as a smoker or a non-smoker. And then we're going to set up our null hypothesis. In this case, again, we have 2 options. We could do an equal proportion hypothesis. In other words, half the people would be smokers, half the people would be non-smokers. But in this case, we're going to do a preset proportion that does not equal 50-50. So in this case, the hypothesized proportion is that 20% of people are smokers and 80% of people are non-smokers. So what we want to find out is if our sample, the data we've collected, will have the same proportion. If it doesn't have the same proportion, is that difference statistically significant? And so that's the hypothesis that we're going to test. So in order to do this analysis, we go to the Analyze menu. We go to Non-Parametric Tests, and we choose Legacy Dialogues, and then we choose chi-square. So as you can see here, we've got all our variables listed. We're going to work with the smoking category or smoking variable, so we move that over into the right-hand box. But again, we could analyze several of these simultaneously. Now in this case, as I mentioned, we're going to test a null hypothesis that has proportions that we're going to preset. The default typically, as you can see here, is all categories are equal. So the default null hypothesis in SPSS would be that there would be a 50-50 proportion in our two potential categories. And the more categories you have, that proportion will change. But in this case, we want to preset an expected value using kind of a different proportion versus 50-50. So in this case, we want to have the first value, which is yes, they smoke. We want to associate that with an expected proportion of 20%. So what we do is we add in that value, 0.2, and then we click Add. So now SPSS will use that proportion of people in category number 1 to compare to our sample. Then we need to add in the 80% value for category number 2 or option number 2. So we add in 0.8 and then we click the Add button. So now the null hypothesis that SPSS is going to test our sample values against is this 20% will be smokers, 80% will be non-smokers. And now again, depending on how many categories you have, you'll have potentially more of these values you'll need to enter in relative to each of the proportions. All right, once we have that added in, we can click on the Options button and make sure that we're getting the descriptive statistics. This is basically going to be the actual values, proportions of values for each category. Then we click Continue, and then we click OK. Now in our output, you're going to get the number of subjects that we had. And then the next table, you're also going to see the observed frequencies, the observed number of people in each category. And then next to that, you also have the expected number of people in each category. So as you can see here, the expected number of people that were smokers, that 20% value, was at 87 people. And then the proportion of people that were non-smokers, that's the 80% proportion, would work out to be about 349 people. So if we look at our observed values, we can see they do not differ terribly from what's expected. Now, to determine if this difference between what we observed and what we expected is statistically significant, we're going to go down to the chi-square value and look at that value, and then we can also look at the significance level associated with that chi-square value. Now, the smaller the chi-square value, the less likely we are to be able to reject the null hypothesis. And this chi-square value of 0.069 is quite small, and that's associated with a high p-value, much greater than 0.05. So if we were going to test the null hypothesis at the level of 0.05, we would be able to accept that null and say that the proportion of observed frequencies in our sample is not significantly different from what we expected from another population or from another sample from the same population. So in this case, we'd be able to accept the null hypothesis and say there is no significant difference between our sample and what we expected to see. So to summarize, what we've done here is a chi-square test for goodness of fit, or also known as the one-way or simple chi-square, in which we had one sample being tested on one variable that was categorical in nature. In this case, we only had two categories we were testing, but you could have any number of different categories that you wish to compare. So hopefully you found this video informative, and good luck using this technique in your own research.